problem number 5. Let me make sure my microphone is on right. Okay, problem number 5. If m to the x times m to the 7th is equal to 28, and they also tell us that m to the 5th, and then that whole thing to the y power, is equal to m to the 15th, what is the value of x plus y? X plus y equals 1. So this is really just a test of whether you know your exponent rules. So what is m to the x times m to the 7th? So your temptation might have been to say 7x, but no. Remember, when you multiply two numbers of the same base, and the base is m, you add the exponents. So it's m to the x plus 7. And they actually wanted to tempt you to do 7x because they actually use the number 28 here, which is a multiple of 7. So they were tempting you to do 7x. But we know that you add the exponents when you multiply m to the x times m to the 7th. And so we have m to the x times m to the 7th. Oh, sorry, I wrote it down wrong. It equals m to the 28th. Sorry. Well, you knew that. Anyway, m to the x times m to the 7th is equal to m to the x plus 7. And that equals m to the 28. So the exponents have to equal each other. So x plus 7 is equal to 28. X is equal to 21. Now let's go here. Here we have m to the 5th, and then we're raising that to the yth power. So here we actually would multiply the exponents, if you remember your exponent rule. So you have m to the 5y is equal to m to the 15th. So 5y must equal 15. 5y is equal to 15. Y is equal to 3. So what's x plus y? It's 21 plus 3, which equals 24. And that is choice D. Next problem. Looks like there's going to be some drawing for Sal in this problem. Try my best. Oh, I thought I was using the little undo. Unedit, undo. Thought I was using the line tool. Okay. It's my y-axis. Draw a straight line. I drew a straight line. That's my x-axis. And then what do they have here? They have 1985. So 1985, 86, 87, 88, 89, and then 90. Let's see. 1985 is maybe looks like about 148,000. So if this is 150, 1985 is here. Let me just draw it all out. 1985, then 1986 is up here at 160,000. This is 140. So 1986 is up here at 160,000. 1987 is a little bit less. 1987 looks like about 150. I don't know. Eyeballing at 156. 1987 is here. 1987 is there. Let's see. 1988 looks like a little bit above 140,000. 1988 is a little bit above 140,000. 1989 is between 130 and 120. All the work here is drawing what you hopefully already have in your book. So where was I? Oh, sorry, this is 1988. 1988 was a little bit better than 140,000. Sorry. Ignore that one. 1989. 1989 looks like about 126. 1989 is 126. And then 1990 is, looks like, I don't know, 112 or something. 1990 is out here. 110, that's 110. And then if I were to connect them, connect the dots, look something like that. Looks something like that. And then let's read the question. According to the graph above, which of the following is closest to the decrease per year in the number of homes sold between 1987 and 1990? So we're talking about from 1987, so it's from this year, to 1990. So how much did we decrease in the first year, right? The first year we decreased by this much. And I'm going to look in the book because I don't know how well I drew this graph. But in 1987, it looks like we're about it looks like about 156,000. 56. And then as we go to 1988, if we go to 1988, it looks like about 142,000, just eyeballing it. Right, so 142,000. Right, so this distance right here is what? It would be 156 minus 142. It's about minus 14,000. Right, that's how much we changed over this 1 year. And if I look at the choices, there already is choice C, which is 14,000. But let me just do one more just to make sure. So if we wanted to figure out from 1988 to 1989, so we said 1988 is at 142,000. Where is 1989? Looks like 120. Looks like 128 or 120. I would say 128,000. I would say this is about 128,000. And so that would also 142 minus 128. That's also 14K. And then if we do the last one, that's 128, and then this looks like about 114 right here. 114. So this is also 14,000. So the answer is C, 14,000. Next problem. Problem 7. Here we have this diagram that shows up actually a lot when you're taking the SAT. I'll show you why. This is a very common thing you'll see. This, let me see, and then there's a line like that. It's a line like that. And then they connect it here. Now let's read the problem. Let's read this problem. I already have a suspicion what they're going to ask. So let's see, this is A, B, C, D, and E. They tell us this is perpendicular. This is perpendicular. This is X. This is Y. In the figure above, AE and CD, AE and CD are each perpendicular to CE. Fair enough. If X is equal to Y, the length of AB is 4, so AB is 4, and X is equal to Y, and the length of BD is 8, length of BD is 8, what is the length of CE? So we're trying to figure out, let me draw CE. Let's have our gold in a different color. We're trying to figure out this line right there. And one thing I didn't write, they told us X is equal to Y. So immediately that should hit a trigger. X is equal to Y, and this is a 90-degree angle. So we know that, X plus Y plus 90 is equal to 180, or that X plus Y is equal to 90. And if they're equal to each other, X must equal Y, which equals 45 degrees, right? So this is 45, this is 45. And if Y is 45, what is this angle going to be? Well, it's opposite to Y. So this will also be 45 degrees. And this is a right angle too. So 45 plus 90 plus this angle has to equal 180. So what's this angle going to be? Well, that's also going to be 45 degrees. This also has to be a 45, 45, 90 triangle. If you ever see a triangle where one of the angles is 90, the other is 45, the other one has to be 45 because they add up to 180. And what we want to figure out is this length here. So I'm going to show you a little trick. And this trick, well, it doesn't always work. It's not really a trick. It's just a visualization exercise, really. And say, we want to figure out this length. Well, that length, I'm going to make the claim, and I think you'll believe this claim, is the same as this length. I'm just essentially creating a rectangle. It's the same as that length, right? So if we figure out this length, we've solved the problem, this light brown length. And we also know, well, let me draw the bottom. Do we know the length? Actually, we don't even have to, of this bottom line. We don't know the length of that bottom line. But we need to figure out this length. We know, since this line is parallel to this line, we know this is a 90-degree angle. Well, do we know the hypotenuse of this 90? Sure. The hypotenuse is 4 plus 8. It's this big red line. And let me draw the hypotenuse in a different color. The hypotenuse, right here. That's the hypotenuse. Actually, I'm running out of time. So I'm going to continue this in the next video. See you soon.